It's one more cool idea I want to show you guys today. Something called Lagrangian points. Okay. So, open up. And so these are points of gravitational stability. Do you guys know a mathematician named Euler? Probably the greatest mathematician in all of history. He worked out the mathematics of these first three L3 points, so L1, L2, and L3. So imagine, can you guys imagine maybe like some L1 point between the Earth and the Sun? Maybe the Sun's pulling you to the left and the Earth is pulling you to the right. Maybe those two gravitational forces balance out. Do you think that could happen? Right? Would that point be closer to the Sun or closer to the Earth? Yeah, closer to the Earth, right? Because the Sun's more massive. So if the Earth is closer, there's some balancing point there, right? Now, that point's not super stable, kind of like trying to balance a ball on top of a roof, right? So if it bumps off a little bit, it's going to just fall off that way, right? But there's a balancing point. Right? Now, because there's also rotational motion involved, you can show that, well, there must be an L2 where the Earth is pulling you to the left, the Sun is pulling you to the left, and if you're in orbit, say along for the ride, then that would act, both of those combined would act as a centripetal force that would pull you to an orbit. So you would appear to be hovering over the Earth just indefinitely as you're making a trip around. Now, you need rotation to make that happen, but that could happen. There's an L2 point of stability. Okay? And then, to play a little bit of logic, well, there must be also an L3 on the other side, a point of gravitational stability. Okay? Before we had space probes, so if you go back to like 1950s and before, it was speculated there might actually be like some like mirror Earth over here. Nobody knew for sure. There was actually some reasons why they thought that too. Good science fiction stories from that, but we've looked over there and there's pretty much nothing over there. Okay? So then years later comes along a guy named Lagrange, who these points are actually named after. He does a bunch of math. I think his point of view was he did a lot of physics through energy and energy conservation was his main perspective, which we haven't even quite got to yet in this class. But when we do, think about Lagrange. He showed there's actually also gravitational stability points at, well, here, L4 and L5. You see these equilateral triangles, equilateral triangle? That is literally the geometry to get to L4 and L5. And actually, those are the most stable points. So if you say park a space probe or a telescope out there, and then it gets bumped a little bit out of orbit, let's say like Jupiter swings by and bumps it a little bit, that's okay, because it'll just kind of gravitate back in place. And I can show you guys an animation of those too. So here are a bunch of asteroids in our solar system that have been mapped. Zoom in. Okay. So the Sun's at the middle. You see Jupiter going around. All the pink dots are the asteroid belt. Hey, that asteroid belt isn't really exactly circular, isn't it? See how it's kind of triangular-ish? Where one point of the triangle, hey, that's the L3 point between Jupiter and the Sun. You see this point over here? It's kind of going around with Jupiter, isn't it? I also see some green patches that are at the L4 and L5 points between Jupiter and the Sun. See if you make equilateral triangle between Jupiter and the Sun and well, each of those green patches, you can do that. Is that? Those green patches, well, those have names. That's called the Trojan and the Greek asteroids. Trojan and Greek asteroids. Okay. Okay, so stop sharing the screen.